In this problem, we want to find the volume of a solid which is a result of a rotation of a bounded area around x-axis. So first, let's focus on that area and see how that area look like and what happens after rotation. Let me just draw the x and y axis. So we want to rotate area or region bounded by this function y is equals to a square root of x minus 1. A square root of x is just like this, something like that. Again, for these type of questions, it's really not necessary to have a perfect sketch, but have a relatively accurate sketch would help a lot. But x minus 1 means shift that 1 unit to the right. So we have this sketch, and to make sure that it doesn't go the negative numbers, because square root only gives you positive values, and there is nothing here on this side, because if you plug in any number less than 1 under the square root, you would have a negative number, which does not make sense and kind of doesn't work in for real numbers. And the other one is x is equal to 4. So this is 1, let's go 2, 3, and 4 here. So x is equal to 4 is just a one vertical line. And the other one is x-axis, the x-axis itself, which is here. So the region which is bounded by these three would be this region. And when we rotate that around the x-axis, what we would get is this part would be kind of a circular part and would be kind of connected. So there are basically a conical shape. I mean, if I want to sketch it maybe a little bit better here. It looks like something like this. That wherever you slice here, for example, if I slice it here, what I would get is a circular cross section. Now, what we want to do is we want to find the volume of this body, the volume of this solid. So to do that, the method that we are going to use is a disk method, which we say, okay, let's slice this. For example, we just take a very, very thin slice from here and we just take it out. Again, these, when we say take a slice, it's a slice from the solid, it's a slice from this three-dimensional shape, which this cross section is circular. So what we are taking out is basically, let me better, it's basically a very thin disk, very, very small layer. So this layer, the thickness of that is very, very small, which because it's along the x-axis, and we would call that dx. It's like delta x. This dx is very, very small. And this disk, the disk also has a radius. So it's a circular shape. It has a radius. And the radius of that, if we look at this graph, this shape, we see that the radius of that is basically the distance of this red curve from the x-axis, which is basically dictated by the first function, y is equal to square root of x minus 1. Basically, the y coordinate of each point here is giving us the radius of that tiny layer. So we can basically say y equal to square root of x minus 1 is the radius. So the radius at this given point, this radius would be a square root of x minus 1. And now that we have this, let's evaluate the volume of this disk. And the volume of that would be, again, it's a cylinder. It would be pi r squared h. The r is the radius, the h is basically the thickness or the height of this disk, which would be pi. R is square root of x minus 1 squared times h, which is basically this dx. This is the volume of a very thin layer of this solid. But we have infinite number of these layers, like here, 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 all the way to this point, which are stacked on top of each other or kind of beside each other to create these three-dimensional shape. So to get the entire volume, we need to add up all of these volumes, or basically sum them up, which we have this S shape here, which we refer to as the integral. So we want to sum up these tiny volumes, x minus 1 squared. So let's just square that first. It's a square of a square root. We can kind of simply get rid of the square root. So it would be pi times x minus 1 dx. There are different ways we can multiply the pi, or we can take out the pi. Easier if I take out the pi, I think. Before that, because we are stacking all of these layers from x equal to 1 all the way to x equal to 4, the bounds of this integral would be 1 to 4. Let's have that in mind. So let me just take out the pi. So I take out the pi because the constant integral from 1 for x minus 1 dx. The integral of x is a very simple function. It's x squared over 2, power rule. And minus 1 would be just simply minus x. And we don't need a plus c because this is a definite integral. So this is the integral. It's multiplied by pi at the end. And we have the bounds from 1 to 4. So now let's simply plug in the bounds. So we have the pi outside. Just let me leave it here. Let's plug in 4. If I plug in 4, I get 4 squared over 2 minus 4 when I plug in basically the upper bound minus when I plug in the lower bound, which gives me 1 squared over 2 minus 1. Let's simply evaluate that. 4 squared is 16. 16 over 2 is 8. Let me just write it here. So this part is 8 minus 4, and this is simply half. So overall, 8 minus 4 would be just 4, and half minus 1 would be negative 1 half. And we have 4 minus negative 1 half entirely multiplied by pi, which is basically pi times 4 minus negative is basically plus half. And the common denominator here would be 2. So instead of 4, I can write 8 over 2 plus 1 over 2, which adds up to 9 over 2. So overall, I would get 9 over 2 here, and I have a pi here. So this would be 9 over 2 pi would be basically the volume of this solid, this three-dimensional object, which is a result of rotating this region around the x-axis.